Hello, my name is Carol Kenrick. I'm a professional practice coach at the Institute of Physics and I teach at a Northrup school. Storytelling is such a powerful tool for a physics teacher. It can help students to understand some of the quirks of our subject, such as conventional current. Teaching them about the stories behind some of the language we use can help them to understand and also to remember it. Stories can also help make our subject come to life. They can be fascinating and they can also show students that physicists get things wrong sometimes, which is quite important for making them relatable. Stories about physics also help us to teach about the nature of physics, how ideas have changed over time in light of new evidence, which is really important. And finally, just a word of caution. We need to think carefully about whose stories we tell. Representation in physics is important to address the stereotypes around who can do physics. If we want to improve representation in the future, we need to make sure that we teach students about a range of physicists. In this video, I'll be sharing some demos. I'll explain them in the static and charge video. This video is about the people and the stories. If you were to ask someone where they think our ideas about electricity have come from, they might mention Benjamin Franklin and his kite, or maybe Michael Faraday, perhaps even William Gilbert. But if you go back 2,000 years to the time of the ancient Greeks, you'll come across Thales of Miletus. The Greek word for amber was electron, and Thales discovered that if you rub amber on fur, it would pick up little bits of feathers, seeds, and other small objects. However, he had no idea what was going on, and a lot of other people disagreed with him. You can carry out a version of Thales' experiments in the classroom. I'm going to recreate this experiment with my cat, Benji. I'm going to give him a head rub, and in so doing, transfer negative electrons to the amber. The amber is now negatively charged. When I bring the negatively charged amber close to these small pieces of paper, you can see that they are strongly attracted to it. Around 2,000 years later, William Gilbert, who was not only Queen Elizabeth I's personal doctor, but also a cutting-edge physicist, designed the Visorium needle. He'd read about Thales' ideas and wanted to test them out for himself. So he carried out tests using a range of different insulators to see whether they would have an effect on the needle. Again, this is something you can do in the classroom. Let me show you how it works. It's literally just a pin in a bit of cork, this diamond folded made out of aluminium foil. So if I take my amber and I rub it on Benji again, and I bring it close to my needle, ooh, you can see it attracts. What if I take a balloon, I give it a fresh rub on my hair? Wow, that is a very dramatic effect indeed. So you can see it's not just amber, other materials clearly have this effect. A little bit later, Peter van Musschenbroek invented the Leyden jar, named after Leiden, his hometown. Whilst this was a very exciting development for physics, the first time charge was able to be stored, the Leyden jar was mostly seen as a parlour trick, a fun experiment that you could do to show off to guests. It's worth noting that whilst it's not very difficult to make a Leyden jar, they can be very dangerous, and it's not something you should ever do with students. Benjamin Franklin was an example of someone who loved Leyden jars. It's well worth teaching students about Franklin because he introduced many of the words that we use every day when talking about circuits. He was known for his kite experiment, which probably didn't happen in real life. He also invented lightning rods, bifocals, and many other things. But more importantly, arguably to physicists, he introduced words like charge, charging, and discharging. He also linked a number of Leyden jars together and introduced the word battery because they reminded him of cannons firing. However, somewhat unhelpfully, Benjamin Franklin, not knowing about the existence of electrons, assumed that the charge carriers that were flowing were positive. And so he introduced the idea that charges were flowing from the positive to the negative terminal, causing much confusion to students across the world. I find it really helps to teach students about this. First of all, so they understand why we have conventional current, but secondly, it does help them to see that physicists are just people. They don't always get things right, they sometimes make mistakes, and importantly, when we find out new information, ideas can change over time. Ideas in physics that we learn about in school are very robust because they've been tested by people over time. Luigi Galvani is another physicist who many students find fascinating. Galvani developed the idea of animal electricity to try to explain why he was able to cause the legs of dead frogs to twitch. At the time, frogs became such a popular resource for physicists that one named Valley exclaimed in a letter, "Sir, I want frogs. You must find them. I will never pardon you, sir, if you fail to do so." But another Italian scientist, Alessandro Volta, disagreed with his explanation. He thought it had something to do with the metals that Galvani was prodding the dead animals with. In trying to explain his ideas, Volta created the voltaic pile, which is what we would recognize as a battery. You can quite easily build your own voltaic pile in the classroom. Let me show you how. Each cell was made up of one zinc disc with a bit of vinegar-soaked cardboard and a copper disc. That is a cell. If you build several cells, what's really great about this demo is it emphasizes that there is a chemical reaction going on in the cell in the battery, because you can see the coins and the zinc washers, there's something happening on the surface over time. So as physicists, we're not going to talk too much about what's going on in the battery. Suffice to say that the chemical store of energy is being depleted. It's also worth mentioning to students that the unit volt is named after Volta. Up to this point, lots of people had discovered many fascinating and quite strange phenomena. However, no one really understood what was going on, what was causing them. It took several hundred years and the work of many, many physicists, most building on each other's work, to really understand what on earth was going on. I'm not going to go into much detail here about the stories behind these physicists, because they're covered in many books and textbooks. I will just mention that it's worth talking about them because this topic has so many different symbols and units, and it can get quite confusing for students. Explaining the reason behind them and the people behind the units can help students to remember them and distinguish them from each other. If we as teachers only teach students about the people I've mentioned so far, they might notice a pattern. All of these people have been men. Have you noticed they happen to be white? This is no coincidence. Up until relatively recently, it was not seen as acceptable or even allowed for women in Western society to study physics or even to study at all. If we don't teach students about a broader range of physicists, they may go away from our lessons thinking that unless they're white and male, physics is not for them. So here are some physicists beyond the textbooks who you might want to teach your students about. We mentioned Galvani, but what about Lucia Galatzea Galvani, his wife? She assisted him with many of his experiments. There are even images of her carrying out experiments in front of fascinated onlookers. Hertha Ayrton made some important contributions to the field of electricity and electrical engineering, but she also made some discoveries related to waves. And Catherine Clark Maxwell, whose husband James is very famous in the field of electromagnetism, helped James out with many of his experiments, not only physically carrying them out, but also intellectually, thinking about the ideas. Over the past century, physics has started to become more representative. When we look at the 20th and 21st centuries, you'll find countless stories of physicists who are working in the field of electricity, many of them working on batteries and clean energy. You could ask students to think about how these physicists' research is relevant to their lives. There are many Black physicists who are not mentioned in textbooks, but students will be fascinated to learn about. Granville T. Woods and Lewis Howard Latimer, inventors. Latimer not only helped to create the first useful light bulb, but also was an accomplished draftsman and drew the patents for Alexander Graham Bell's telephone. Mary Jackson, the first African American woman engineer at NASA, who was featured in the book and film Hidden Figures, and Dr. James West, who worked at Bell Labs and who helped design the foil electret microphone, which is the first small microphone that didn't use a battery. These are now used in countless applications, including hearing aids. To learn about more stories on this topic, take a look at our Stories from Physics booklet by Richard Brock. The series is available on the IOP Spark website.